Hello, I'm Stefan Kreber, I'm the project leader for LXD, and in this video I'd like to provide a bit of an update on the microcloud initiative that we've started a few months back. What we have so far is the ability to deploy a very easy to use LXD cluster on as few as 3 machines, with both LXD and Ceph being deployed so that you get distributed storage. Now, for the past few months, we've been working on expanding that. Part of it is we've now added the ability to configure local storage as well. So you can choose between both very fast, but not highly available local storage and much slower, but fully redundant distributed storage for your instances. The other thing that's been missing from the beginning, and we knew we were going to be working on that, is virtualized networking. The initial microcloud we put out, and that I showed in a previous video, was using the Ubuntu fan as the main way to do networking, which does allow for instance-to-instance communication across the cluster. That's great, but it doesn't provide with IP address stability as part of moving instances around, which means that if one of the machines would go down and you need to relocate that instance on another system, it would work, but with a different IP address, and that's causing obviously a bunch of issues. It's also not quite as flexible as our recommended solution, which is OVN, in the sense that OVN can apply pretty complex network access control lists, can apply load balancers, do floating IPs, do a lot of different things for us. And so we created a new project called MicroOven that does the same thing to OVN as MicroCloud does to Ceph, which is effectively provide a self-clustering layer with a REST API that MicroCloud can drive. And with that project now being stable, we've updated MicroCloud to make use of that, which now makes it very easy on, as few as 3 machines to get a functional LXD cluster with both distributed storage and distributed networking. And in this video, I'm going to be going through what this now looks like as far as the initial user experience for assembling such a setup, and also just throwing some workloads at it and just seeing how that all works. All right, so switching over to a terminal here, we can see that I've got 3 systems. They're all identical, and unlike in the past video, those are not virtual machines. They are physical machines that are in my basement. And they're all ARM-based systems. So if we look, there are 4 cores and they have 8 gigs of RAM. So it's somewhat similar to a Raspberry Pi 4, except this is actually an Odroid M1, which has the benefit of actually being in stock and something you can actually buy, unlike the Raspberry Pi 4 supply chain situation. Now, one thing they have going for them compared to something like a Raspberry Pi 4 is they've got a PCI bus that's actually accessible. So I've got an NVMe SSD in each of them. And they also have SATA support. So I also have a SATA SSD in each of them. So we can see that my setup here is the main OS is installed on a micro SD card. Then I've got an NVMe SSD that provides very fast local storage. And then I've got a SATA SSD, which provides slower, but still SSD-backed storage. The way I'm going to be setting things up is that the very fast SSD is going to be used for local storage in the microcloud, and the other one is going to go into Ceph to provide remote distributed storage. On the networking side, what I've got going here is the board only has a single network interface. So OVN requires its own dedicated network interface that it can do as it will. It can't have any IP address or anything on it. So what I've done here is I've created a VLAN on top of that one NIC I've got. So that's that VLAN 200 that you can see here. And that VLAN is unconfigured on the Linux side, but it is on a subnet that actually is functional. There's a gateway, there's everything on that subnet. So if you were to put an address on it, it would work. And that's what OVN is going to be consuming as its uplink. So that's the network that OVN will pick IP addresses from for each of the virtual networks to provide routing to the outside world. So in this case, I'm using a VLAN. You could also be using a dedicated network interface for that. You could be using like a virtual function on top of an SRIOV capable NIC. There are different options, but you need to have an unconfigured network interface that can be fully consumed by OVN for this to work. All right, so now let's actually set up the cluster. Actually, first, let me show you the snaps that are installed. So what I have on this system, it's an Ubuntu 22.04 system, and I've got the LXD, MicroCloud, MicroCloud, and MicroOven snaps all installed, all coming from the stable channel. So if you were to install that clean, you would do something like this to get everything installed on your system. The reason why I'm not doing that now is simply because those ARM systems are pretty slow, and just that step can take something like 2 or 3 minutes on those. So I pre-installed them to make things a bit faster. Now, once they're installed, all you've got to do is pick one of those 3 systems, or one of the whatever many systems you have. You can go as far as 50 effectively, and you run microcloud init on one of them. This is going to prompt you to select what network you want to use for the control plane of your control plane and data exchange, so Ceph and OVN traffic. For your microcloud, I'm going to pick that IPv6 address here, then hit enter. And then it asks me whether I want to filter the list of other servers based on the subnet I selected, which is usually what you want to do. So just do yes. And it shows me what was detected on the network, which is the other 2 servers. Select those and then go forward. What that's going to do now is it's going to connect to those to all of those servers and scan the hardware to know what's available as far as storage and networking. Then it prompts us to configure local storage. We could do without it and just use distributed storage, but in this case, we've got the disks, so might as well. And it shows us the list of everything that was detected. You can filter the table easily enough. So if I type NVMe, I just get the NVMe drives, and that's what I want to use for local storage, so I select them all. Then it asks where I want them wiped. In this case, I have no idea what's on the drive, so I'm just gonna have them wiped. But if you're not too sure and there might be useful data on your disk, probably don't want to do that and instead let the process fail if any data is located on the disks. So that's gonna wipe those disks and prepare them for local storage. Then it shows me what's left. So do I want to configure distributed storage? Yes. And it shows me those remaining SSDs that can be consumed by Ceph. I'm gonna select them all and again, tell it to wipe them all. And now we're moving on to the networking side of things. So on that front, we want to configure distributed networking, which is OVN. And it needs us to select that one unconfigured network interface on each system. It could have different names, that doesn't really matter, but we need one per machine. So in this case, I'm gonna select them all because that's all I have here. And then move on. And then it asks me, okay, well, those are connected to the same subnet. Tell me about the subnet. So that's my IPv4 subnet. And the first address that's usable for OVN is going to be 100 in this case. That obviously depends on what you have going on that subnet in your case. And then I do have IPv6. I'm going to configure that. If you don't, you can skip it. Oops, 62 D200.1/64. And that's it. That's all the questions that you need to answer to get both Ceph and OVN going inside of a microcloud. At this point, what's going to happen is it will initialize all of the services, so microcloud, LXD, MicroOven, and MicroCeph, on the initial server that you're running microcloud init from. And once that's done, it will talk to all of those individual services to issue join tokens. Those join tokens will then be distributed to the other systems in the cloud to similarly configure those services and join the microcloud. So we can see we're pretty much done here with the initial system. So it's about to start issuing those join tokens to the other 2. At which point that will take a little while because Ceph specifically can take on those kind of low powered system up to a couple of minutes to prepare the disks and join them. So that's the part that can take quite a bit of time. Running that on modern x86 hardware would probably go significantly faster. Here I'm using 3 boards that are about equivalent to Raspberry Pi 4, so they're very, very low powered and also quite slow, so that takes a little while. While that's going on, something I can mention is some of the constraints around storage. So if you want local storage, you will need to pick exactly one disk per machine. You can't have a machine that doesn't have a disk for use for local storage. So that's something to keep in mind. And then Ceph can consume anything else, anything that's left, but there's also a bit of a constraint there. You need a minimum of 3 drives for Ceph to function, but you also need drives on at least 3 servers. So if you only have 3 drives, each of them must be on a different server. In this case, that kind of works out because, well, I bought the hardware specifically for this. So I've got exactly 1 NVMe and 1 SATA SSD per system, which means I get to give 1 to local storage, 1 to distributed storage, and it all works. But if you're dealing with more of a mix of configurations within your rack or your lab, then that's something to keep in mind. You're going to need to make sure things are properly balanced, potentially moving drives around or potentially skipping either local or distributed storage, depending on what you have available. So at this point, the clustering is done. So all of the services have been clustered across all 3 systems. And all that's left now is to have LXD itself get automatically configured for this. So microcloud is now talking to LXD. It's creating storage pools for local storage, remote storage. It's creating an uplink network for Oven, and it's creating an initial Oven network on top of that. And once that's all done, we're going to get the shell to return, as it just did now, and the microcloud is functional. So let's take a look. If I look at my cluster here, we can see we've got 3 systems in there, everything looking good. You can actually go look at all of the other clusters too if you want. So microcloud cluster list gets you the same thing on the microcloud side. Then microceph will do the same thing for microceph, and lastly microoven for microoven. So you can see that all 3 clusters are set up, everything is online, everything's looking good. Now, if we look at what's happened on the storage side in LXD, as mentioned, we've got both local and remote storage configured there. On the networking side, we're gonna see an uplink network was defined and a default Oven network was defined. If we go look at that default Oven network, we're gonna see that it's got allocated some addresses in our uplink subnet. So that's the IPv4 and IPv6, and we should be able to ping those. And what's answering there is the virtual router within Oven. And that's working just fine. Now, if we go look at the default profile that was generated, we're gonna see that the network is going to that Oven network, and the storage is going to the remote storage by default, so on Ceph. Okay, so let's launch some instances. I'm gonna be starting with probably one of the lightest images we have, so it's an Alpine image. And just start a container with default config. That's gonna place it on, well, download the image and then place it on Ceph. While that's going on, we can actually go on the other 2 servers because they're all part of the same cluster. They all see the same thing, and we can actually launch more things. So we can do another Alpine image, and this time let's put it on local storage. Then we can do an Alpine VM that will live on Ceph, and as it's a VM, we need to disable secure boot because Alpine does not support it. Okay, and now let's make things a bit more interesting. Actually spawn some Ubuntu as well. So we'll do an Ubuntu container here, and then maybe we can do another Ubuntu container, but this time on local storage. I'm just gonna wait for the image to be downloaded on the first one. That will just save us a bit of bandwidth there, because as soon as the image is downloaded on one of them, all of the others get to access it pretty easily. So just to wait for that. Okay, it's been downloaded, so now the second one can go ahead and can download it from the first one effectively. And that will get us effectively a set of 5 initial instances, 4 containers, 1 VM. And we can see how everything is working on the networking front before looking at maybe creating another Oven network. So I'm pretty much just waiting for that Ubuntu, one of the 2 Ubuntus to be done so I can get a shell back. Again, things are a bit slow here, but it's worth keeping in mind that this is all running on extremely low spec ARM systems. Like pretty regularly, you're gonna have just a BMC in a normal server would be faster than this. So this is really your worst case scenario as far as performance, but it still shows it works perfectly fine on boards that are not even like $100 per board. It's really quite interesting to see how low spec you can make a microcloud effectively and still have something that works. All right. So that Ubuntu container is almost done. Okay, the first one looks like it's also almost done. We'll see which one's going to be fastest to start up. Okay, I think Ceph beat local storage by a tiny bit. And the VM is still ongoing. That's not too surprising. It's a larger image, even when using Alpine, and VMs on those boards, while they do support it, definitely not something I would run at any kind of large scale. That being said, it's done now and it's starting up. So all good. Let's go look at a instance list. So we can see all 4 containers are currently up and running. The VM is currently starting up and now it's running. All right, so let's take one of the Ubuntu containers and we can try and ping the other one. So 1965. And we can see that the first container is located on micro 01, the second container is on micro 02. They are on the exact same subnet thanks to OVN, and they can ping each other. So it's so good. And we should also have IPv6 connectivity. So we can talk to the outside world, no problem. So IPv4, IPv6 to the outside works perfectly fine as well. So that's pretty much what you get with a microcloud. Now what we can just try and do is create an additional network. So do a network called foo, put it as type OVN. Because there's only one uplink network that's defined, LXD will automatically use that. You don't need to mention it. And it's gonna get us another network. So if we go look at it now, there we go. Again, we got some IP allocated on its uplink. So we can go and ping that. Here we go. And here we go. So that's working perfectly. And now if we wanted to place another instance on that, we could do launch images, say Ubuntu 2204. We're going to use the one that's on Ceph. That should actually be fastest since it's already loaded. As view 3, and we'll do network foo. So that's going to allocate another container running with storage on Ceph, and it's going to be connecting it to our new network called foo. Once that's done, we can just make sure that, again, networking works properly inside of that instance and that it can't reach the other ones, because OVN networking is by design completely isolated and virtualized. So while they can all talk to the internet, they can't talk to each other. Instances within the same network obviously can, but instances from another network cannot do that unless you go and define a network peering inside of LXD, at which point they'll be allowed to do it. Okay, so now I'm in that instance. I can ping the outside world, and I cannot ping the other instances. Sorry for the loud beep. Looks like there was a tiny power glitch here. Thankfully, my machine is on UPS, so that didn't actually impact anything. All right. And apparently it was also short enough that the machines in the basement thankfully did not die over that, so that's good. All right. So looking at the list right now, we can see we've got 3 Alpine instances running, 2 containers, 1 VM, 3 Ubuntu containers running across 2 different OVN networks, and everything is all working just fine. Maybe just to wrap it up, I'm gonna go inside of the Alpine VM. Alpine does not have bash, I keep forgetting that, and just show that, yeah, this is a virtual machine, it's running on ARM on that cluster, and it's working perfectly fine. If you want to just make sure the storage looks correct, you can always go look inside of one of the instances. This one we can see dev RBD, so we know it's on Ceph. And this one we're gonna see a ZFS dataset, so we can see that this is running on local storage on ZFS. And that's it. Thanks very much for watching. If you've got any questions about microclouds and how they work, you can go on our community forum that's linked below and ask questions there, or leave a comment on the video and we'll keep an eye on that as well. Should be very easy for you to test this for yourself. You effectively just need either 3 physical systems you can play with, or you can do it in virtual machines on on a single system. I would just caution against trying to do this in the cloud, because one of the requirements for OVN to work properly is that the uplink must be an actual L2 subnet that it can take addresses from. This is not generally true with what the cloud providers provide, as far as like VPCs and the like. So you're probably not going to have a good day. The detection logic that's used to find the other machines is also using multicast through MDNS, and that's also usually not supported by the various VPCs in public cloud providers. So I wouldn't expect this to really work in the public clouds. Again, run that, if you don't have spare machines, run that inside of virtual machines on your system, and that should work just fine. Anyway, thanks for watching, and I'll see you in the next one. Bye.